Welcome back everyone. In today's video, we will discuss about decorators, which is an advanced topic in Python. As a Python programmer, you definitely need to know about decorators and how to use decorator. So in this video, we will cover what is a decorator, how to implement decorator, why should we use decorator. Before explaining Python decorator, let's take a real life example. If you have a party in your house, like a birthday party or a wedding party, then we decorate our houses, right? With a lot of flowers, balloons and lights. We need this decoration only for that particular event. To add this decoration to our house, we are not doing any changes to the house, right? Like constructing a new room or removing a room, right? We only add these decorating items in our house. Once the event is over, the decoration will be removed and the house will look like the old stage. Similar to this, we have a decorator in Python that add the functionality without changing the current function. So decorators allows you to decorate a function without changing the function. Let's imagine that you have a simple function that returns some value. Now you want to add some additional functionality to this function. So you need to add additional code to the existing function, right? What we basically do is add the extra code to this existing function and use it. But in this case, you can't reuse the old function because you had made some changes there. Maybe we can create a brand new function with old code and new code, but that is not a good method. We only need to add that extra functionality whenever we need it. So we have a problem here. We can overcome this situation using decorators. Python has this concept called decorators, which is a special function that modifies or enhances an existing function or method. It allows you to add functionality to an existing function without changing its code. Now we can easily add an extra functionality with a decorator. As you can see in this code, this is the way how we can add the decorator. We need to add @ symbol in front of that decorator. So this decorator connects to the extra code with the current function and execute. And if you don't want to execute that additional functionality, you can delete that @ some decorator line on top of that function. So it will only execute that old logic. Now we can check how this decorator works in the background. So we are going to build a decorator. Here we have a function called viewBooks, which basically returns a list of books. I want to add additional functionality to this method. If the users have enough permission to read, then only we should return the list of books. For that, I want to add a decorator. So I add a decorator called require permission. In this decorator function, we add the script to check users' permissions. If the user doesn't have enough permission, then we are not returning the list of books, but returning the permission error message. To add the decorator to our function, we can use @require permission on top of view books. So it will first check the user permission, then only returns the list of the books. If you remove the line @require permission, it will directly return the list of the books. Let's break down the require permission decorator line by line to understand how it works. Require permission takes a single argument permission, and inside the require permission function, there is another function decorator. This function takes an argument function which represents the function to be decorated. So basically we are passing the function viewBooks through this argument. ViewBooks is the function that we need to decorate. Inside a decorator, there is another function wrapper. This function will replace the original function, which is viewBooks in our case. Wrapper function takes user as its first argument, followed by arguments and keyword arguments to accept additional positional and keyword arguments. Inside the function, it checks the user permission. If the permission is not found, it returns the error message. If the user has the required permission, then a wrapper function calls the original function with that same user and returns the result. So the wrapper function is nothing but wrapping up the original function with the additional logic. Means that the original function is now replaced by the wrapper function with added permission logic. This structure allows the require permission decorator to dynamically add permission checking behavior to any function it decorates. So you can not only decorate the viewBooks function, but also decorate other functions. Let's say a function delete book. Only thing that you need to add is add the decorator line on top of the delete book function. It will add that permission logic with delete function as well. Also, If you don't need that additional permission check in later stage, you can delete that decorator line on top of the function. Then it will only run the old logic. So it is very simple to add and remove that additional logic. So the summary of this background process can be listed in 4 steps. First one, create decorator, which is a function that takes another function, or we can say the original function, and do some logic, then returns a new function. Second one, apply decorator. Use @decorator name on top of the function that you want to decorate. Replacement. Python replaces the original function with the new function returned by the decorator. Execute. When the decorator function is called, it runs the code in the wrapper function, which includes calling the original function and additional behavior defined by the decorator. Why decorators are so important? Here I list out some of the points. First one is code reusability. Decorator allow you to reuse code for adding common functionality across multiple functions or methods. Second one is separation of concerns. Decorator helps in separating different concerns or functionalities from the core logic of a function. Third one, enhancing functionality. They allow you to enhance or modify the behavior of a function in a clean or modular way. Fourth one, dry principle. Decorator help adhere to the don't repeat yourself principle by avoiding code duplication. Fifth one, cleaner syntax. They provide a cleaner and more readable for applying cross-cutting concerns. So these are some of the major points about decorator. What are the common scenarios that we need to implement decorator? So here some of the typical scenarios where decorators are particularly useful. First one, logging. If you want to automatically log function calls and their result for debugging or monitoring, you can use decorator. Authorization and access controls. If we need to check if a user has necessary permission before executing a function, we can use decorator. For example, to check the role or permission before allowing them to access certain functionality. Third one, caching. If you want to cache the result of expensive function calls to improve performance, you can use decorator. Validation. You need to validate inputs or outputs of functions before they execute or after they return. Timing. You want to measure and record how long a function takes to execute, you can use a decorator. These are only some common cases that we use a decorator, but you can add a decorator whenever you need to add a reusable code. In today's video, we covered the concept about decorators. I will post more advanced videos in Python, so please consider to support the channel. Thank you for watching and see you in the next video.